Alright, so today what we're going to do is we are going to graph a quadratic equation, and the way that we can tell this is a quadratic is by looking at the leading term, or the term that has the exponent with the highest degree. And so you see that the highest degree of this polynomial is 2. So it's a second degree polynomial, so we know that this is going to be a quadratic equation, and if I go to graph this, I'm going to end up with some sort of parabola. Now there's many different ways we can do this. What we could do is we could try to maybe plug in numbers, we could even try to find the x-intercepts here, and we also have different equations that can be used to find the actual vertex of this. But I'm going to show you how you can do this by completing the square. And what that's going to do is it's going to get us this equation into a form that looks like a transformation. And by doing that, we'll be able to clearly see where the vertex is, and we'll be able to clearly see what is happening in terms of whether this thing is, curving up, curving down, and, how it's being stretched or compressed in many different ways. Alright, so first let's try to complete the square. Well, you might be asking yourself, how do I complete the square on this? First off, I don't have this set to 0, so I'm not completing the square to solve an equation here, so that makes things a little bit more complicated. And also you might see, well, how am I going to complete the square with this coefficient on the outside? If I remember, completing the square, this first term, this x squared term, always has to have a coefficient of 1, or it can't have anything greater than 1 in order for me to do that. Well, what we're going to do here is we're still going to work inside those two terms right there. When completing the square, you want to usually work with the x squared term and the x term. And we'll leave the constant term alone for a moment. Well, whenever you're completing the square with something that has a coefficient here, what you have to do is you have to factor it out. And the easiest way I think that one can do this is by taking whatever the coefficient is and basically factoring that coefficient out of this expression here. And so now that I factor out a 2, well, what I'm going to do here is I'm going to enclose the next part of this in parentheses. 2 times x squared is 2x squared, and 2 times negative 2x is going to give me negative 4x there. So you can see that this expression and this expression is equivalent, and we're just going to drop down the plus 1. Well, now what I can do is I can complete the square inside the parentheses. And I want to make sure I'm careful here. I want to make sure I enclose this expression inside these parentheses, so eventually I'm going to use brackets here. Well, in order to complete the square, if it helps you in any way, you can draw a box with 4 squares. And we know that in order to complete the square, what we're trying to do is we're trying to add a square that makes this thing a perfect square, so makes the sides equal to each other. And so the first box, x times x, is going to give me an area of x squared. And what I need to do is I need to take this second term and I need to split it within 2 boxes. Well, to split negative 2x in half, I'm going to get negative x and negative x here. And in order to get the area of this box to be negative x, well, x times negative 1 is going to be negative x, and x times negative 1 here is negative x as well. Well, in order to get this extra box, what I need to do is take the length of this side and the length of this side, which you see are both negative 1, and multiply them by each other. And so what I'm going to get here is an expression that is x squared minus 2x plus 1. Now the thing is when I'm completing the square here, I'm adding a number that allows me to make a perfect square. You can see that the sides of the lengths here are x minus 1 and x minus 1, so I can say that this is x minus 1 squared. But in order for me to be equivalent to this expression, what I need to do is I need to also take away this number that I have as well. So let's rewrite this, and I'm going to use brackets now because I'm going to have x minus 1 squared in this expression. So 2, and I'm going to use brackets because remember we completed the square inside the parentheses. X minus 1 squared. And remember that that is this right here. Now that we added a 1, what we need to do is we need to also subtract that 1 next to this expression, because this and this are now equivalent now that I've taken away this 1 right here. And that might be a little confusing to you at first, but try, using this, completing the square method a few times. You may have seen in previous expressions, if you were completing the square, that when you had a 0 on the other side, you might have to add whatever that number is to the other side. I personally like to write it this way at all times because of these more difficult expressions that we might get. And now that I've closed this off, I can now just drop down the plus 1 that's here. Okay, so I got this in this form for a reason. So I don't want to expand that back out again, or it's just going to get me back to here. But what I can do is I can multiply this 2 into each term of this expression. And when I say term, first term is x minus 1 squared, and remember that that is one whole thing, and negative 1. Well, 2 times this is just going to bring 2 on the outside. 2 times x minus 1 squared. And 2 times negative 1 is just negative 2. Combine like terms here. Negative 2 plus 1 is just going to be negative 1. So now that I've done this, I have the right side of the expression like this. And I didn't write f of x this whole time just because it would have been redundant. But anyways, how does this help me? Well, if you know transformations, and you know the blueprint of the transformation of a quadratic equation, and this can be done with any sort of blueprint equation. We're taking x squared and we're basically transforming it in some way. Well, now that I have this in this form, I now have my a equal to 2. My h, x minus 1, or x minus h, now my h is 1, and my k is negative 1. Well, h and k is what gives me the x-coordinate and the y-coordinate of my vertex. And then a basically tells me not only is this thing going to curve up or down, but also tells me how it's going to be stretched. Okay? So, if h is equal to 1 and k is equal to negative 1, well, if I go to graph this thing, the vertex of this equation, or this function, is going to be at x equals 1 and k equals negative 1. Now, it's interesting because realize that the a value here is also the a value in the original function itself. When we think of the quadratic equation, we have a, b, c. Well, this a here also corresponds to this a here. And what this tells us is this function is being stretched up by 2, and because this number is positive, we're not flipping the equation in any way, it's just a positive parabola here. And what I'm going to do, rather than transforming points on this, I'm actually just going to plug in a point, x equals 2, and I'm going to figure out what the output is. Because what's going to happen here is at the vertex, realize that this thing is going to have a certain amount of symmetry around the vertex. So if I can find whatever the output is at x equals 2, well, I can figure out what the output is at x equals 0 because it's going to have that similar symmetry here. All right, so x equals 2. So 2 minus 1 is 1. 1 squared is 1. Times 2 is 2 minus 1 is just 1. So we have the point 2, 1, which means that if the axis of symmetry is around this point, that means that if I go from the vertex and I go up 1, 2, and to the right one, then up 1, 2, and to the left one must also be a point on this graph. And I could do the same thing for x equals 3. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. Minus 1 is 7. Okay, so 1, 2, 3, 4, 5, 6, 7. So I have a point at 3, 7, which also means that, so 1, 2, 1, 2, at negative 1, it also must have a point at 7. Okay? And so there's my graph, and there's my parabola. And so by completing the square, what ends up happening here is you end up being able to derive certain equations that can get you to this step much faster. You can actually find the vertex by using a simple formula around these coefficients, and then you can plug in different points to figure out, where they lie along this parabola. And you can also use x-intercepts here to find this as well. But anyways, if you forget those formulas, because it's never great to just memorize formulas if you don't know where they're coming from. The quadratic formula is also done by completing the square here with more arbitrary values. But now that you understand how to complete the square in order to get this into a transformation form, then you don't have to worry about those formulas as much if you forget them. Okay? So this is the graph, and this is how you can complete the square, and this will also help you if you're trying to solve a more complex quadratic equation and you have that coefficient on the outside and you're not exactly sure what to do. Alright, I hope that helps, and be sure to subscribe and make sure you leave a comment below so I can see what kind of questions you guys have and maybe some content that I can cover in the future. Alright, bye.